Want to look at covariance between two random variables. Now, covariance between two random variables is denoted like this, either covariance xy or sigma xy. Now, this can be calculated using this particular formula where covariance between x and y is the expected value of x minus expected value of x times y minus expected value of y. Now we can derive another form for the covariance formula, which is expected value of xy minus expected value of x into expected value of y. So we can see that when we're finding covariance between two random variables, this essentially involves knowing how to find expectations using the joint PMS, something we already looked at in detail. So here what we're going to focus on is that whenever we talk about two variables being related, we talk about three things. The first being in what form are they related? And here we're talking about is they linear relationship or non-linear relationship. The second thing we talk about is the direction of relationship. Is it a positive or a negative relationship between them? Third is a strength of relationship. Is it the relationship strong, weak, or moderate? So these are the three things we need to look at whenever we're talking about two variables being related. So let's apply these to covariance. Now, when we talk about covariance, the first thing we want to look at is the form it measures. Now, covariance only measures linear relationship between the two random variables. It does not talk about non-linear relationship. So whenever we're looking at the covariance between two variables, it's measuring the linear relationship between them. Covariance tells us nothing about non-linear relationship. Now, sign of covariance tells us whether there's a positive or a negative linear relationship between the two random variables. So if the covariance between x and y is greater than 0, so there's a positive linear relationship. If the covariance is less than 0, there's a negative linear relationship. If the covariance is 0, then this means there's no linear relationship, because remember, covariance only measures linear relationship between the two random variables. It does not talk about non-linear relationship. So when covariance between two random variables turns out to be 0, so we say there's no linear relationship. This does not necessarily imply independence. More on this later. Right, so it's important to keep in mind covariance measures linear relationship. The sign of covariance tells us whether there's positive or negative linear relationship. If covariance is 0, because we know covariance measures linear relationship, so the interpretation of that is there's no linear relationship. Based on this, you cannot conclude the independent. More on this, like I said later. Now, covariance tells us nothing about the strength of relationship. Like we discussed, the three things that we want to look at, right? One is the form in which form they're related. Covariance measures linear relationship. Then you want to look at the direction of relationship. The sign of covariance tells us that is it positive or negative linear relationship. But covariance tells us nothing about the strength of relationship between the two random variables. Now, this is because of two reasons. One is that covariance can take on any value on the real number line from minus infinity to infinity. It's unbounded. The second reason is that covariance is unit sensitive. If you change your units of measurement, value of covariance changes, even if you have the same probability distribution. So falsely assumes that strength changes with change in units. So with covariance will tell you the direction of relationship, but it cannot measure the strength of relationship. It can't tell you is it a strong, moderate, or weak relationship because of these two reasons. So to solve the above two problems, that how covariance is unbounded and it's unit sensitive, because of which we cannot use covariance to measure the strength of linear relationship between the two variables. So we can standardize it where we divide covariance by the standard deviation of x and the standard deviation of y, and the resulting measure is what is a correlation coefficient. More on this in a bit. Right, so over here, we talked about covariance between two random variables. And like we said, it measures linear relationship between the two random variables. And the sign of covariance tells us the direction of relationship. Covariance cannot measure strength of relationship. It can't tell us whether the relationship is strong, weak, or moderate because of two reasons. It's unbounded and it's unit sensitive. So to address this problem, that covariance cannot measure strength of relationship, we come up with a new measure known as correlation by standardizing covariance.